A couple of comments about the value of notation or symbols. You're already familiar with this definition of f of x having a limit of L as x approaches a. This is the exact wording of that we've been using, and this is a lot of words. In fact, you have to read it pretty carefully to be sure what it is saying at all, and to make sure you haven't missed something or misunderstood something. You could write this out every time you work a limit problem. You could work this out. You could write this out step after step after step as you work your way through a limit problem. But in most cases, what we choose to do is write out this. This is an abbreviation for all those words. That's the power of mathematics and the power of symbols. You can see that at a glance. Once you understand the symbols, you are able to drastically cut your work and increase your understanding, because you can see at a glance what that big long sentence of words, you could easily miss something or misunderstand what it's saying. In a similar vein, these are some phrases that we're going to use over and over again in talking about continuity. F of x is continuous at a, f of x is continuous over the interval, closed interval a, b, and f of x is a continuous function. You are welcome to use those phrases and to write them out in detail every time you're working on a continuity problem, or when you're stating continuity theorems. You'll just be doing a good deal more writing than maybe you would need to if you used a more compact notation. So we're going to propose an ad hoc notation that will simplify this process if you wish to use it. There's no standard notation for this. There are various ways that people have construed to write abbreviations for continuity, and this is one way that it might be done. So instead of writing out those words, often these will be things that will be used in this course. This is the proposed symbology to represent the first statement there. F of x is continuous at a. It simply asserts C for continuity. Strange brackets so it's not confused with anything else we might put in brackets, the function f of x and a. So it asserts the continuity of f of x at a. If you wish to write out the words, f of x is continuous at x equals a, feel free to do so. The second line, f of x is continuous over the interval from a to b. This is the proposed notation. It asserts continuity of f of x over the interval ab. Again, you may write the words or you may write the symbols when you're answering questions on tests that ask you to state continuity laws and that sort of thing. The last line, f of x is a continuous function, is asserted as continuity of f of x. So here's the definition of continuity in three different forms. The top form is simply all written out in English words, still using the function notation. We're not writing out function of x, but f of x. The middle portion there is using some of the terminology we have about limits, which requires less writing. And then the bottom one is full symbol mode, which asserts continuity of f of x at a, if and only if, that is, we're going to define here the meaning of these symbols in terms of what continuity at a point means, and it's 1, the value of the function exists at a, the limit of the function exists at a, and the two match. That's the statement of continuity.